Hi everyone, welcome to Methods 2009 Exam 2. We're going to be starting on Section 1. My name's Abe and we're going to be going through this section as quickly as possible so that you have lots and lots of time to do those questions later on in the exam that are much harder. Okay, getting into it. Question 1. This section's all multiple choice. So the first question goes, you've got a system of simultaneous equations and a constant k in there, and they want to know when you have some unique solutions. So when you see this kind of thing, right, you should think matrix. Also think for unique solutions to exist, you need determinant not equal to 0. Okay, so maybe a smart kind of thing to do would be to calculate the determinant, right? So for question 1, you'd say, great, determinant of this system, you should just be able to write it down, is k minus 3, 5, and then negative k plus 2, like that. And you know that you want that to not equal 0 for unique, right? So why don't you just solve for this thing equals 0? So you know that the determinant is equal to minus k plus 2, so you cross multiply, right? And then times minus negative 3 times 5, it's going to be plus 15. And you want to equate that to 0, solve that equation, and you're going to get k equals negative 5 and k equals 3. Great. So basically you want anything but k equals negative 5 and 3. Go back, have a quick look. You want obviously B, D, or E because they include the reals and then accept stuff, and B is the right one. There we go. First question out of the way. Be happy with yourself. Question 2. Okay, question 2 is good in many, many ways. No working required. Notice that they want to know what's going on at point 1, 1. Look at this graph. Y equals x minus 1 all cubed plus 1. This graph has only got one feature, which is a stationary point of inflection at 1, 1. You can't have local max, local min. The gradient is defined at all points, and there's no points of constant continuity. So the only answer that could possibly make sense is C. So I'm just going to say shape. Question 3. Maximal domain. Okay, again, not a very hard question. You know that log x is defined. Log x for x element of what? Real plus, right? So basically what you need to see is that the inside of the log needs to be larger than 0. So 2x plus 1 bigger than 0, you're going to get x bigger than negative half. And you come back here and you say, great, x bigger than negative half, or x, if you express it as this interval notation, you get negative half to infinity. So, B. There. Question 4. Speeding through this. General solution to sine of 2x equal to negative 1. Okay. It's not super easy. You need to write something down, but it's not very difficult either. Okay. So you know that sine of negative pound 2 equals negative 1, right? So 2x equals negative pound 2. And what period is this? The period is actually going to be 2 pi, right? So you go negative pound 2 plus 2 pi n, where n is an integer. I'm just writing this down to show you. Please don't write this down in the exam. It's going to waste you lots of time. And so x is just going to be negative pound 4 plus n pi. That's it. Really simple. Notice that there's only one solution to this. One solution in 0 to 2 pi. right? So this is a special case when the sine or cos of something equals 1 or -1, you only get one solution. So yeah, there's only that one solution. And you'll find that this solution corresponds to answer A. Ding. Great, isn't it? Okay, 4 questions out of the way. We are ahead of time and we are caning it. Let's get going again. 5. Okay, so here you're asking which one of the following is not true. When you have one of these, there's no real way of going about it. I mean, you can't just go, this one is not true, unless one of them is immediately obvious to you. This may be obvious to you, but if it's not obvious to you, eliminate the easy options first, right? The easy ones look like A, B, and C. So for A, you'd be like, okay, so xy squared equals x squared y squared, right? That's what it's saying. It's about right. That's no problem. Sorry, change font. For B, you'd say, well, x squared minus negative x squared equals 0. That's also no problem. For C, you would say, well, f of 2x is 2x squared. Is it going to be the same as 4 times x squared? Again, no problem. Look at D. What does D imply? D implies, what is it? Sorry. X minus y squared is equal to x squared minus y squared. You all know that's not correct, is it? You all know that's not correct. Because when you expand that out, you're going to have some kind of middle term going on. So D is the incorrect one. Some of you might have been able to pick that just by looking at the question. D sometimes would have looked obvious. E is not something you should try unless you're not sure, because it just looks like it'll take too long in an exam setting. So yeah, there's an approach to solving this which of the following is not true type questions. Okay, on to question 6. So you want to relate your random variable x to the standard normal, so it seems in this question. And so you go, okay, great, you can do that. Z equals x minus mu over sigma. And you want, what is it? You want the probability of x being greater than 17, right? So z greater than 17 minus the mean, 14, over sigma. So z greater, sorry, not smaller. Apologize for that. Let me rub this out. Oh, I just realized now you haven't been able to see any of that. Good, you didn't see my mistakes. Z greater than that, and you evaluate that, you get z bigger than 1.5. So that's the probability, right? The probability of you being bigger than 17 is the same as the probability of z being bigger than 1.5. Quick cursory glance at the solutions says there is no x bigger than 1.5. Okay, so find a geometric equivalent. X bigger than z bigger than 1.5 is going to be the same as z smaller than negative 1.5, right? Because it's symmetrical. So you look at that, yep, there you go. Answer D is right there. So for those not clear, very, very quick little graph. Goes like this, the normal distribution, 1.5 is here, negative 1.5 is here. So this area here is going to be the same as this area here. And so you can pick either area for your probability. Okay, next question. Question 7. So for some function, find the rate of change of y with respect to x when x is 0. Really easy. Use your calculator. Find, what do you need to do? You need to find dy dx, then find what? Dy dx at x equals 0. If you did this in your calculator successfully, you'll see that the answer is 2B. There you go. Question 8. Sum function. Again, calculator is the easiest one. You know what it's going to look like. It's a positive cubic, so it's going to be roughly this kind of shape. That kind of shape, right? And use your calculator. You know that one of the turning points is going to be at x equals -5 because there's a square on it. Use your calculator to find the other turning point. You'll discover that this turning point is at x equals 1. So 8 is C. There. Question 9. Question 9. Tangent. Tangent at some point has this equation. Now, what's the new equation of the tangent if you move this curve? Well, find out the translations. So you'll agree that if my curve moves up like 2 units and across 2 units, the tangent's going to do the same thing, isn't it? So look at what happens. You want y equals f of x minus 2 plus 3. Okay, good. Apply that transformation to the tangent. So basically sub in the tangent as f. So why don't you just do, okay, y equals, now f is now 3 plus 2x. 3 plus 2x. X is now x minus 2 plus 3. Do you see that this part here is, oh, I'm sorry, I haven't shown you what I was drawing. That part there is f of x minus 2. And continuing in smaller pen, you can expand that and simplify things, and you'll see that you get 2x plus 2. 2x plus 2 is option E in this case. Great. Okay. We're doing okay. We're doing alright. Question 10. No. You get given a distribution. All you need to do is remember how to find the median for one of these. Remember what you do? You just go from the lowest value, so x equals 0, and you got 0.4, right? And you increase until you pass 0.5. Whatever number you use to pass 0.5, that's the median. And if you get exactly onto 0.5, then you have to go halfway between this number and the next number. So yeah, let's do that. So we're up to 0, and we've got a probability of 0.4 so far. When you get to 1, oh look, 0.6, we've passed 0.5. The median is 1. And that's option B. Easiest question on the exam, probably. Question 11. Alright. So you get a probability density function, and you're saying the value of A such that the probability of x bigger than A is 0.2. Let's quickly draw, just very quickly, draw what this thing's supposed to look like and think about how to solve it. I'm not even going to draw the shape of the graph. This is my graph. Okay. Now it says that we're running from 0 to half and then 0 elsewhere. So half is there, and our graph is going to look like something random. Alright? Like that. That's our probability distribution. And it says, oh crap, what have I done? And we're saying that probability of x bigger than A is 0.2. So coming back to our graph, if I draw in this point A and color this thing in, I say I want this as 0.2. Okay? So basically all you're saying is, alright, 0.2 is the integral of f of x dx between, what are the two terminals? A and half. And basically, you just find A such that this equation works, or is closest, What you'll see is that there are probably ways to do this on your calculator just by one go without guessing, but here there's not many values to guess. Guessing is faster. So what I would do, try the middle value. No good, maybe, or maybe good. So yeah, if you tried A equals 0.2, try A equals 0.32, and you'll find that actually it's too big. Your area is too big. So then try A equals, that means you need to get your number higher. When your number is higher, you're closer to half, so the area will be smaller. 0.35, and you'll find that you're very close. But maybe just try that top one just in case, and you'll find that you're further away. And so this one is the winner, and you'll find that the answer to 11 is D. Question 12. Alright. Question 12. It doesn't look like something people will like. Question 12 talks about transformations. A lot of you don't like this. There's an easy way of doing it. Let me show you. 12. Okay. So you see that you start out with y equals sine x, and then you become y equals 1 minus 3 sine 2x plus pi, right? First thing you want to do, you get from, just write that down, sine x becomes, what's it become? 1 minus 3 sine. Now, remember that you want to take out the 2 here, so you get 2x plus pi on 2. The reason you want to do that is because you want to separate. In this form, it's easy to see the transformations that occur. So you see that here, the 2 means, a dilation, and that pi on 2 is actually a shift. If you had just 2x plus pi, you wouldn't be able to tell. So yeah, here you go. Now, the next thing to do is just to make a matrix out of it. You just have to remember the elements of this matrix, right? So the transformation matrix. So you just go, okay, the transformation is, alright, so what have we done to sine x to make it into this thing? First of all, top left is for, what's it for? Dilation from the y-axis. Dilation from the y-axis means, give me different color. That's dilation of half from y-axis, right? We actually squashed it in closer because we increased the frequency. Good? So, half goes in here. Now, what about dilation from y-axis? That's the bottom right. The dilation from y-axis looks like that, right? Minus 3. So it's a dilation and a reflection. Minus 3. So what does this minus 3 do? It stretches the graph vertically. Dilation from the x-axis of factor 3 and reflected. So it's minus 3. So you stick minus 3 in here. Oops. Better color. Minus 3. Okay. And then, sorry, I've written over where I want to write the equation. That's okay. So you know that x, y go here. Plus, now, these are the translation parts, right? So translation in the x-axis, where's the translation? Pound 2, right? Which direction did it move? Left. So negative. Negative pound 2. And then, okay, what about the translation in the y direction? That's easy. We have this 1 here. And so that's just 1. And in case you're wondering, with these other bits inside the matrix, that's 0 and 0. X doesn't get transformed depending on y, and y doesn't get transformed depending on x. So there it is. Constructed our thing. Constructed our matrix just from the equation. And now just go back, have a look, and say, which one matches? And you'll see that option D is exactly what you need. At the start of the question, it probably would have been good to just a quick look over the answers, but in this case, it would have been very difficult for you to actually pick what was going on. Well, actually, you could have just done the matrix and not worried about the translation part, but that's okay. So that's 12 out of the way. One of the harder questions on the exam, I think. Question 13, fair coin toss 12 times. At most 4 heads are obtained. Real easy, right? You all know how to do this. You know that x is distributed as a binomial, 12 trials, probability of success is 0.5, and you just find probability of x smaller or equal to 4, and you're going to find that this is 0.1938, option C. Straight up calculator operation question, nothing really to see. 14. Okay. Which one of the following is not true for this function? Several approaches. 1. It helps if you know roughly what this looks like. To give you an idea, it looks roughly like a square root graph. Just roughly. But with one difference. It sort of continues onto the negative side. Also because it's an absolute value. Okay. There's a lot of options you can take. You could just go through them one by one. Or if you have a quick glance, you'll notice that B and D are contradictory. If you find one of these, which one is true, which one is not true, and then 2 of them are contradictory, you know that the other 3 are irrelevant. So B says the gradient is not defined at some point at x equals 0, and then D says there's a stationary point there. So obviously they can't both be true. You know that at x equals 0, right, this thing has some kind of cusp, because this graph, you see, this graph looks something like this. Looks something like that. Without the absolute sign, it would sort of come down here a bit, like that. So you've got a cusp going on. This cusp will ensure that the gradient at the point 0, 2, or at x equals 0, is not defined. There. D is the answer. So, lots of ways to come through this answer. I mean, an alternate way to answer it would just be, why don't you just work through A, B, C, D, E and see which one is false? That could be another way of doing it. Graph it. Maybe that will help you too, if you couldn't imagine that graph in your mind. So yeah, lots of reasons, or lots of different ways of doing this, but it certainly helps if you have a quick glance of the answers, and if you see something contradictory, you know that there's something up there. Okay, question 15. Just find dy dx for some function that's not specified. It's not too bad, right? You all know how to do this. 15 says, well, dy dx is, just do a straight chain rule. So remember, you just keep 1 minus f of x as the inside of the function. That's alright, you don't need to know the function. And then you're going to multiply by the derivative of the inside, which is negative f dashed of x. And that answer matches option D. Sorry, option E. I wrote it correctly. Question 16. Great. You want to find the inverse of a function? Okay, quickly. Before you write anything down, you know that A, B, and D are all wrong, right? Inverse of an exponential is going to look like a log. So let's just get that out there. Okay, so it's going to be either C or E. Keep that in mind. Keep that in mind. You'll see that okay, so 16. Whoop. You'll see, okay, to find the inverse, you just swap x and y, so x equals, what, e to the 2y plus 3, and you'll get 2y plus 3 equals log to the base e x, and then you get y equals half log e x minus 3 on 2. Go back to the answers. You'll see that the only one that looks mildly like it is option C, and it's got log root x, but you know that this half can go inside, right? And if that were to happen, our thing would work. So, option C it is. Good, isn't it? Notice that we didn't have to worry about the domain because it just wasn't necessary for us to look at. Okay. Question 17, onto some probability type things. You've got a sample space and a variety of outcomes. They want independent. What does independent mean? Probability of A times the probability of B is the probability of A intersection B. So in other words, A and B are not related events. What can you do? To be completely honest, not much here. All you can do is find the probability of A, probability of B, and then find the probability of both of them together and see if they multiply out to each other. No special tricks, but they've been very nice. So you'll see that in answer A, that probability of the first one, so just the first set is 6 on 12, half, right? The probability of the second set is 4 on 12, you get 1/3. And the probability of first intersection second is 2 on 12, which is 1/6. And so this happens to work. A. Great. If the answer was E though, you probably would have had to try all of them out and see. I don't see a really easy way of doing this question. Okay. To question 18. Average value of some function. They give you the average value and they want to find the interval. Okay, so you've got some kind of thing to solve, right? So let's write down the equation and start from there. You get 1/6 of log 7, and this question is one where you probably do need to write down some working. Is 1 over the interval, the length of the interval is k, and the integral 0 to k 1 on 2x plus 1 dx. Yeah? So that's the equation you need to solve for k. Doesn't look nice, that's true. But what can you do? You can integrate it yourself. You're going to get 1 on k, and then half of log 2x plus 1. And your terminals are k and 0. And then you'll see, okay, that's 1 on k. Sub in k for x, you'll get half log 2k plus 1 minus, what happens if you sub in 0 to x? You get log of 1, which is 0, minus 0. Great. Okay. So, time to do some comparison. Here you go. 1/6 log 7 equals 1 on k, or 1 on 2k, log of 2k plus 1. you can see that if you just try some values in there, the outside, well, 2k, this part kind of has to equal 6, right? I mean, you could swap things around, but let's just try that. So k equals 3 is going to work, and oh look, if you stick that inside here, k equals 3 is also going to work. And so you can sort of conclude, great, k equals 3. And if k equals 3, then the answer is B. Done. Okay. 19. Here we go. Okay. So we've got a graph, and it goes, we want to find the shape of 1 minus f of 2x. Okay, what does these transformations do? First of all, you expect this graph to be inverted. You expect this graph to also be squashed together, because x has now become 2x. And also you need to expect for it to be increased by 1. So looking at our options, see if I can get them all onto screen. No, that's okay. You'll see that, well, D and B are not inverted. A's been stretched out too far, and really E is the only inverted one that's been squashed a bit. You can see, right? E is the one that's been squashed a bit, and that's the only inverted one that's been squashed a bit. So without too much trouble, we say 19 is E. Almost there. We're almost there. Question 20. Oops. Should turn the page before I stop writing. Question 20. Okay. Number of solutions for this funny looking equation over negative 2 pi to 2 pi. Great. Okay. First thing to realize is that a is a constant, so you don't need the absolute value sign. Just assume that a is a positive value, and you can divide through by a. So really, what you're trying to find is absolute value of cos 2x equals 1. Right? So you can go, great. Now let's find cos 2x equals minus 1 and cos 2x equals 1. Right? Okay. So make life easy, and remembering that x has to be between negative 2 pi and 2 pi, you know that, okay, obviously cos 0 is going to work. Cos of 2 pi is going to work. So if it's 2 pi, if 2x equals 2 pi, then x equals pi. And if 2 pi is going to work, 4 pi is going to work. So at 2x equal 4 pi, you get 2 pi. So you see that our solutions are spaced out by pi in this case. So there's 5 right there already. Now, for cos 2x equal minus 1, you know that for this thing to equal minus 1, 2x has to equal what? Pi, right? Cos pi is minus 1. So if 2x equals pi, x equals pi on 2. And you know that this thing's also spaced by pi, isn't it? Because the other set of solutions, this set of solutions was spaced by pi. This set must also be spaced by pi. So you go pi on 2, great, 3 pi on 2, and then negative pi on 2. And there's probably more, but you can stop now because you have 8 solutions already, and this thing says how many solutions do you have, and the max is 9. So you sort of confirm for yourself, that's great, because you can also put in negative 3 pi on 2. That's 9 solutions, 4 on the left, 5 on the right. And we get away from this saying, awesome, it is option E. 9 solutions in that 4 pi period. 21, home stretch now. Home stretch. And 21 is an interesting question. Very interesting. see it this way. 21 goes, cubic function has a rule. So all you know that it's a cubic, so, and it talks about the graph of the derivative function. It goes, there's an intercept at 2, 0, another intercept at minus 3, 0, and there's a max. Okay. Doesn't look like too much information. And you want to find where the local maximum is on f of x. Okay. Smart thing to do, draw f dash. So let's draw f dash. F dash looks like this. So we've got an intercept at 2 and minus 3. 2 minus 3. And you know it's a parabola because, well, it's a cubic. The real function's a cubic, so the derivative is a parabola. Great. And there's a maximum, meaning that it's this shape. Okay, cool. And now it wants to know about the local max. Let's write a little bit about the gradient of this thing. So we know that for this section left of minus 3, the gradient is negative, right? Because our line's beneath the x-axis. For this middle section, gradient is positive. And for this last section, gradient is negative. Okay, maximum is when we go from positive to negative. That is the maximum. 2 at x equals 2. Great. B, 2. There. 21 is B. Last question. See if we can squeeze it onto this same page. Alright. The final question says, okay, you've got a region, curve of sorts, exact value of the area of this region. Okay. Smart thing is probably to sketch it. So let's sketch. It's bound by x-axis, y-axis, line with equation y equals 3, and then y equals log of x minus 1. So if you were to draw this, it looks something like this. You go, okay, now this is the line, y equals 3. We've got the x-axis, y-axis. The graph of y equals log of x minus 1. Well, you know there's a asymptote here at x equals 1. You also know that the log graph goes like this. Okay, let's say it meets the graph here. And what's this value? This value here is 2, actually, because remember at x equals 2, you get log of 1 on the inside, and log of 1 is 0. Awesome. So you go ahead and do this with your calculator. You could go ahead and find the area in an intelligent kind of way. Okay, so obviously if you were to find the area just like this, you'd have to split the area, right? You'd have to go, you need to find this block. Well, the area of that is not very hard. That's just 3. And then you find this bit in here. Except that part means that you have to find this intercept. So you go ahead and find that intercept, and you can find that part in there, and you know that'll work. That'll work. You'll get A equals 3, right? 3 is that shaded area, plus integral from. Now your calculator is going to tell you that this point here is e cubed plus 1. E cubed plus 1 to 2 of 3 minus log to the base e x minus 1 dx. And you could go ahead and solve that. That's probably a reasonable way of doing life, but there's another way. The other way is to integrate not with respect to x, but with respect to y. So you just change the equation around. You know that if y equals log to the base e of x, log base e x minus 1, you know that x, when you transform things around, is going to be e to the y plus 1. And you can go area equals integral from y equals 0 to y equals 3. So from here to here, 0 to 3 of e to the y plus 1 dy. Both of these are going to give you the same solution, and it's going to be e cubed plus 2. That's going to be the solution. So regardless of the approach you take, you're going to come out with that, and the correct answer will be D. Personally, I like the second method. Some of you might not like getting your head around that one, and the first method is there for you. But I really do think the second method is quicker. And with that, we're done with the multiple choice section, onto the longer questions. And that'll be covered in our next video, so don't go away. See you in the next video.